Okay, I
Hi.
think I think it's there. Okay, okay, yeah. I never know until I actually see the timer go off, and it's always on delay there. All right, hello once again, guys. Okay,
Hi.
we are back once again. See, I already see him lurking up there. Okay, so you
Dang.
gotta chill. Don't worry. Okay, all right, get your high in. Okay, and don't worry.
Hi.
Okay. Yes, Brianna's here once again. It is happy St. Patrick's Day, everybody. Even though religion isn't doing much in the way of observing and things like that right now, but that's or Catholic religion anyway, but that's neither here nor there at the moment. That's not what we're here for. We're here for math. And of course, yes, wearing the green. The only green I've really got is any of my New York Jets paraphernalia and stuff like that. Which hey, Jets fans, are how excited or nervous or whatever are you about the announcement this morning that Tom Brady's leaving the Patriots? So
Scale 1 to 10. How excited are you?
yeah, I can only imagine. I mean,
25.
well, like I told you and mommy this morning, it's not a foregone conclusion that suddenly means that the division is wide open. Will it be helpful? Perhaps, but
Yes.
Bill Belichick has weathered the quarterback storm before. Whenever Tom Brady's been injured or suspended or whatever the case is, so that is what it is. It'll make next year very interesting, especially especially when we find out who will ultimately replace him in New England. But hey, that's why football is so exciting when it happens again, when all sports happen again. So I mean, it'll be good when we finally get some normalcy back in life again. All right, but that's the that's life outside of the math course or whatever. So we are ready to roll here with some new stuff. So anybody that was here yesterday or stumbled upon this after the fact or whatever, okay, what it is that we're about here. We're gonna be here for at least an hour every day. Bring your math topics, bring your math questions, whatever it is that you want. The live chat is open here for you to send your information in as to what you want to know. We'll put up examples and sample problems of whatever topics it is that you like. As a matter of fact, Brianna jumped the gun before we got here because as she was doing her distance learning packs or whatever, she had a question which was getting her a little stuck or whatever the case is. Well, yeah, she did solve it correctly, but what was interesting about it, and I wanted to bring this question to attention today because you can see we got a word problem from her fifth grade stuff displayed here on the board.
Word problems.
Well, believe me, a lot of people don't like word problems. But listen, I've said this to my students before many times over, Brian. I'll say it to all of you out there that are watching. One thing you have to kind of understand here is that math is a language. Okay, it's just as much a language as the English that we're speaking, as Spanish, Japanese, or any thing else out there around the world, or when you're working in computer code and stuff like that.
All the ones and zeros.
Exactly. It is a language. And the thing you have to understand is that you have to be able to translate it to get the information out of it that you need just as much as you do anything verbally that you're speaking. So just because you're dealing with something that revolves around numbers doesn't mean you don't have to read words and you have to translate sentences and thoughts properly and stuff like that. So you got to try to master it and pick out the information that you need and how to process it in terms of calculations. So keep that in mind as we work along. With that said, here is with a slight twist in the objects involved in the question. Okay, here is the problem that Brianna ran into a little while ago before we started this, and we'll talk about what you're supposed to get out of it.
Jaden has 56 Pokemon cards in a pile.
Okay, read it and don't tap every single. No, I'm saying don't tap every single word because then your words are getting drowned out by the tapping.
Jaden has 56 Pokemon cards in a pile. Jaden divides the cards evenly into 4 albums and then buys 2 more cards for each album. How many cards does Jaden have in all?
Okay,
so originally I thought
go ahead.
that you had to divide 56 by 4 and then do this stuff to get 4 to get 14.
Okay, now what is
not right?
Yeah, well, what does that 14 cards actually represent? Let's at least
how many cards are in each pile?
How many cards are in each album or are going to go in each album as of right now?
Okay.
Okay.
And then I think after I did that, since there are 4 albums and it says he buys 2 more cards for each album, I did 4 times 2, which is 8.
Okay. And I'm going to tell you, I'm going to tell you and everybody else now that actually is one of the one of the key necessary calculations involved in this particular problem. But go ahead.
The extra cards you bought.
Go on.
If you already had 56 cards already, so then turns out you had to do this. Edit.
Okay. Yeah, the 56 cards she had array plus the 8 cards. Yeah, having the details of the and so she has 64 total cards, and that is the correct response. That's what you're supposed to end up getting and stuff like that. That's how it should have worked out. Where Brianna was getting stuck or confused or whatever initially when she was first reading this problem, without the extra detail, is the whole dividing the cards evenly. So she was trying to figure out, okay, is she supposed to take the 56 and multiply it by 4 or divide it by 4? That's how it was initially starting, or whatever the case is. So and yeah, it's a natural instinct to try to take and go with that information. And usually most of the word problems that you will ever encounter are going to have a lot of keywords and phrases that will tell you directly exactly what operation you're supposed to be doing with the numbers at any given moment. But every once in a while, and this situation does happen to be one of them, every once in a great while, you will come across some mathematical information that is in some way, shape, or form extraneous, meaning that it's unnecessary. You either don't need that particular number, or the thing that it says that you're doing with it, you don't need it in some way, shape, form, or capacity. So the idea of dividing 56 by 4, that's the extraneous operation here. You don't need to do that.
Wait, Dad,
but the 4, as you saw,
because there's another problem.
Well, I know we have to discuss that other division because you hadn't worked with that type of number yet, but we'll get to that in a second. Okay, but the 4, as in this case, the 4 was still a necessary number, just not in the way you were expecting. The 4 actually combined with the 2 because you have 4 albums, you're buying 2 extra cards for each album. So that was the reason for actually taking the 4 and multiplying it by the two extra cards per album, or for each. Each you want to try to use as a key word to stress that multiplication is happening in that type of circumstance. So for that reason, then you did the 4 times 2. That's what gave you the 8. And then in all, that's one of the key phrases representing that you're doing some type of addition. And so then doing the 56 plus the 8, and that's what gets you the 64 and stuff like that. So that's the kind of thing you want. Why are you taking a picture of it?
I want to save this.
Oh, you're saving the picture. You're saving your little drawing, or whatever the case is. All right. No, I wasn't sure. No, I'm saying if you're gonna send the math to your friends, why don't you tell them to watch the show? Okay, because
I was gonna erase it, and I didn't want to erase it.
I got it. Well, here, leave the drawing. Get rid of the other stuff. Yay! Okay. All right.
Can I keep Derpy Pikachu?
No, I need that space for other stuff.
Can I keep Pokemon?
I might need that area too. Just leave the.
Yay, Jaden!
All all the fun of that business. However, okay, all right. So let's see. So now as you were going through your packet, you were
There's another problem.
Okay, now well here wait before oh wait another word. Okay, all right, go ahead. All right, we can do another word problem. Sure.
Can I
Okay,
write
while we're
that?
waiting for some more people to check in and things like that. However, hopefully. Yes, if nothing else, please keep me company, folks. So ever while we're doing this, I got to fill an hour of content at least every day. So no,
Can I change up
anybody that's watching, I see there's one person out there watching. Whoever that person is, please by all means, chime in with a math question if you got one or whatever. It could be any K through 12 topic. We'll do anything here.
I'm just gonna change this so it actually fits our living room because we have 3 windows.
Okay,
no, I'm gonna keep it as 4.
Yeah, keep the confines of the question because we don't want to run into any issues or whatever the case is. All right, but here, give the so that we can save some time here. Like I said, read the details of the question as we're going here and stuff like that. So this way, I know exactly what I'm expecting. What's the question say?
It's about windows.
Okay, all right, but oh wait, which question? Okay, all right. As she's writing it, I'll read it off of her page or whatever. So we're so it says, all right, there are 4 windows in the living room. Each window has 1 set of blinds and 2 panels of curtains. The blinds cost $20 each. Each curtain panel costs $28. How much do the window treatments cost as a whole? Okay, a lot of good information to process here to be able to put all that together, get your totals and stuff like that. So they're giving you the number of windows. They're telling you the contents of each window and what the numbers are. So the fact, once again, you've got that that key word within the problem that's saying what each blinds or curtain or whatever costs. So again, each again stressing the word multiplication in this circumstance. So we know that there's going to be multiplications involved. What it just comes down to is knowing exactly what numbers that we're multiplying. Now, there's a couple of different ways that could all be crunched together and stuff like that, or spelled out. You decide how it is to best see fit. You see, these are those circumstances that we probably want to summarize the information a little bit, so you're not losing time spelling out the literal entire question. You know what I'm saying? But while she's doing that, here we'll get all the key numbers that we have put in place here. Okay, so it's saying that the window has 1 set of blinds and the blinds cost $20. So you know that your first multiplication is for the blinds, the 1 blind times 20. Okay. Yeah. What are you doing? But okay, understands. Remember, I've been operating at a high school level, so usually the floating. Okay, well either. Okay, well. The debate rages on. All right, at least okay. All right, enough. Okay, I got the idea. Yeah, obviously teaching at a high school level and knowing the ideal in algebra and variables and stuff like that, knowing that X is a common variable, you start to, at my level, get out of the habit of writing the times symbol as an X. You put it as that floating dot that literally floats mid-level in the height of the numbers, or put one of the numbers in parentheses to indicate a multiplication that way. So just recognize that 1 times 20 can read like this, it can read like this, or it could read like this. Any of those are acceptable as a form of multiplication. So that's the story there. Okay, give me the rag. All right, so but
one of Joey's shirt.
But point made. But point made, regardless, we know we're still multiplying. So the blinds is okay. Wait, all right. Let me write some stuff. Okay, so we know that for a single window, you got 1 blind. It costs $20. So 1 times 20, you've got the 20. Each curtain, okay. Each curtain, you've got 2 curtain panels on each one, and each curtain costs $28. So you do the 28 So you do the 28 times 2, and that ends up giving you an amount of, okay, all right, she's going to get it. So she gets 56. Okay, so overall, we take those and we add that together, and that gives you the cost for one on win. Okay, so it's $76. It's $76 of adornments on each window. But then you have to recognize you got one more multiplication for the number of windows that you actually have in this room. So 76 times 4 in this case. So we do that multiplication and we end up with a total of, as you see, okay, 24. Yes, because you have 7 times 4 for 28, plus the 2 that carried over from 6 times 4. So it ends up being a grand total of $304 adornment for the setup here. Okay, so that's the way that plays out.
That's a lot of money.
Well, hey, imagine. Well, hey, look at you know how mommy likes to watch shows like the Property Brothers a lot and stuff like that. We got any Property Brothers fans out there and things? So those kind of, okay, all right. You're getting a little too fancy with the art there and stuff like that. You got to be careful there.
Money.
Yes, I got it.
Money. Money. That's everything.
Yeah, that's what Donald Trump drew in kindergarten. So.
Oh my God! Dad! Dad! Why? Why would you say that?
And I don't care if you like him or not. It's again, it's see, I'm going for the everybody can laugh at it humor. Okay, so
except Donald Trump.
You don't have to like him to appreciate the joke. Again, that's what we're about here. We're having fun and having a little laugh with it, in addition to trying to actually get stuff done. Okay, you got to have a little humor with this stuff in life. That's what we're about here. Okay.
But here's the thing: he can't laugh about the joke because it's about him. And what if he didn't draw the picture?
Well, yeah, he does have a. He's not good at self-deprecation. That's very true. But okay, again, all right.
Neither
okay,
am I.
we're rambling on. Okay.
Yeah,
Anywho,
I want to.
So all right, but
money.
Okay, but that's the point.
Money.
Okay, but coming back to the point, that's the key of the question here. Like I said, and that would probably be the best way you could organize this information. You know, just like get the costs for one window and stuff like that. You know, there's going to be a master multiplication when everything is said and done, but just micromanage each individual piece of the calculation, get it all sorted out like this, and then get your master multiplication of the times 4 windows when everything's said and done, and you're good to go. So that's how you want to lay that out. You could have also just as easily, with the things there, knowing that you've got 1 set of this and 2 set of that, you could have also reorganized this all as an addition by doing 20 plus 20 plus 28. You could have written it as a series of additions that way too, and gotten the 76 that way, which is the same as that is down there. And then again, the times 4 when it's done, or write out a series of 4 plus 76s, whatever it happens to be. No matter which way you organized it or sliced it out, you're still going to get that $304 when everything is said and done. So you play it as you see fit, and then you're good to go. So that's the nature there.
Okay. To spell subscribe backwards.
Okay, but they're gonna read it backwards.
Can I borrow one of these? No.
They're gonna see it the way we do.
Dad. Can I borrow one of these?
Quick,
sure.
All right, go.
No.
Okay. No. That's how we see it right now, because the camera is showing a mirror image of ourselves.
So wait.
Okay. So you didn't watch yesterday's thing, did you?
No, I did. It's just.
Never mind. Okay, let me move on.
Dang it!
Let me move on with the material here. I'm sorry. I gotta get rid of Mr. Moneyface here. Okay?
Mr. Moneyface.
I will leave your. I'm leaving that one up there.
You know which Jaden I'm talking about, right?
No, I don't. So, what is that? Friends of yours or?
No.
Well, tell me. I don't know what you're talking.
You.
Okay. All right. What is that supposed to be? What is that?
Jaden.
Who is that?
Jaden. Jaden.
I don't know what Jaden Animations is. Okay, we're plugging something apparently here.
I don't know. It's just I realized that it was Jaden. I'm like, oh, yay. I just felt like drawing.
Okay, who knows? Anyway, all right, okay, all right.
Drawing Jaden is hard because
Okay.
it's the hair. The hair is hard. The hair's hard to draw, okay, with the swoopy thingy.
Where's Bob Ross when we need him?
The happy
Yeah,
little tree.
yes. See, she knows. Okay,
Happy
all right.
little tree.
All right, okay, all right. Let's switch to let's switch to another item here. Okay, now, now this is something that when you were going through your order of operations stuff yesterday later on, this was after the broadcast was over yesterday.
The truth of PEMDAS.
Okay, no, not that. No. We're going to talk about that when we get videos started for you again. No, I'm going to address that anyway because that was part of the next video that we're going to do. But no, that wasn't the point. No, no. One of the problems that you had in your order of operation work yesterday. Okay, just all right. Thank you. But that wasn't the point of this. No, the problem was that, no, you got confused in one of the problems that you were doing here, that you did the correct calculation first that you were supposed to, but you got thrown off by, but wait, there's a remainder. What happens there? Okay, well, okay. All right, just right. No. We don't need the whole question. We just need that one division. Just set up just the one division. That's all we need to worry about. Hey, write a little bigger because I want to make sure our audience can see here. So, yeah, you can write bigger numbers. You're allowed. You don't have to write that big.
You're telling me to write big, so I'm gonna write big.
Okay, all right. Well, here. Well, the +5's not the part we're worried about here. Okay, all right. You don't have to underline it either because I need the space underneath. Okay, all right. We're not worried about the. Okay, what you're worried about is this because this was the circumstance that you had not run into yet, or rather, you had run into it. But show what you have been doing with divisions up until this point. And she did the 4. Okay, and then she had that.
Sticky.
Okay, so she had up until this point, any divisions that she had been doing up until now, she was getting the if she had a remainder, she wrote it as a remainder. The problem was in the order of operations problems that she was doing, she had that extra operation coming afterward and stuff like that. It's like, okay, how are you supposed to deal with the +5 when the thing's got a remainder? All right. This is where, and at the moment, she has not done these yet. It's in her workbooks or whatever, but they skipped over these chapters she hasn't done the chapters on decimals yet at the moment or whatever. So she hasn't done really any operations with them, or at least very little just yet. So we kind of had to do a little bit of a crash course here on this one just to get around this particular problem, which we'll do right now. So, and I'll do an extra example with these decimals in a minute, especially with the division discussion. So the idea here is that, okay, so you got one left, but if you want an exact answer to this type of stuff, yes, okay, all right. Now I know who one of the audience is. It's you, okay, but I want to know who else is out there. Whoever else is watching here, please. Whoever else is watching, please chime in. Say hello. Okay, please chime in. Say hello, and submit whatever questions that you like here. Okay, but anyway, coming back to this.
Interrupt you. Okay, I don't want to be rude.
I understand. I know we talked about that, but anyway, here's the point then. So to try to settle this with regards to decimals or whatever the case is, the idea is that now what you would do is now you have to start a decimal, and the idea is that, okay, you have 49 whole, so that means that your decimal, you officially have no decimal, so you create a 0.0. Now, the thing is, since you have a remainder, you're going to need that 0.0 to be able to continue the division problem there. and that's what it's going to come
So
out
that
to. It
means
comes out to a point.
little
It comes out to
smaller.
a 0.5 in this case, or whatever, because then you do the 5 times 2 for the 10. Let me get in there, and that gives you the nothing that's left, and you're officially done. If you need to go further, then you supply extra zeros, as many as you need to supply in order to be able to complete the question. And that's assuming that the division can be completed, because naturally, as you go further down the road, you're going to run into some circumstances where the decimal is never ending. It will likely, if the division is like this with 2 rational numbers, it will have a repeating pattern if there's a never-ending decimal involved. But beyond that, that's still in general how you would try to navigate to find either where the decimal stops or where it ultimately where the repeating pattern ultimately begins. So you know when to quit, and you could use the bar notation to express that. Now, in cases like this where it's whole number times whole number, whatever, coming up with the decimals in those circumstances pretty straightforward, whatever. Now, some divisions you may see will already have decimals on them and stuff like that in certain ways, shapes, and forms. Like, what if you're doing a division of the following? Let's say you're taking a number that already has a decimal involved on it. Let's take a 46.2. Okay, you try this, Bria. Take a 46.2 and divide it by 3. Okay, so let's see how she handles this. Okay, if anybody watching, if you've got an answer, go ahead and supply. Okay, so she counted a single 3 out of 4, so she did that subtraction. She counted 5 3s out of 16, still has 1 left. She brings that down. Okay, and then how many 3s out of 12? You get 4, and that evens out, so you got it there. Okay, so okay. So 15.4 is the end result there and stuff like that. Okay, so there's
if you do it like
there's another example. And if you needed more places, if something happened that you need more decimal places, then we go on from there. Like, what about
if you do it in fractions? Could you like turn the 0.4 into a half, the fourth?
No. You can turn the decimal into a fraction, yes, and depending on how you need to use the number for other purposes or other calculations, yeah, it's important to be able to know how to translate. But a decimal but you have to understand when you see a decimal like that, okay? Because no, I do see that happen a lot. I do see a lot of people, they'll see a remainder of of 1, and they'll and no matter what, they'll call that a half or something of that nature or whatever. But the thing you got to remember is that you have to always remember that that place values in general, every place value that you run into, whether it be ones, whether it be tenths or 10, whether it be tenths like the decimals, you have to understand, remember how the digit system works. Every digit that you run into, it operates operates off of a base 10. The base 10, based on the fact that, like I said, you've got 10 digits.
That means it would be,
you got 10 digits from 0 to 9.
so
and once you get to 9, yes, because as soon as you go from 9, you go back to 0 and the cycle repeats. That's what base 10 means.
Oh, it's because,
okay.
Can I erase some stuff?
When you look at this, yeah, it's 4 tenths. So yeah, it's 4 out of 10. And if you want to reduce that, you can go ahead and do so and call it 2/5 if you needed it in that capacity. So that's the nature there.
We have
and who's pinging me here? Go ahead while you continue.
Since we're in the 10th. Since we're in the 10th place.
I like who's pinging me.
Since we're in the 10th place, that means.
Okay, so trying to.
15 and 4.
Oh, it's one of us.
Since it's in the 10th place, that means you'd be in it would be tenths. Because we're not going like that, adding a bunch of zeros to the end of it.
Yeah, no. You don't have to. You have to do that. Yeah, zeros at the end.
It would be the thousands place. So it would be
Okay, well that would be 10,000s. Because
10,000.
this is tenths, this is hundredths, thousandths, 10,000ths.
So it'll be like in the thousandth place. So it matters like the place value.
Yeah, pretty much.
Yeah, I learned something new. Because fraction, but for some reason we always do fractions before decimals, but in the book, decimals come before fractions. So.
Well, yeah, I mean, and everybody's going to approach it differently and stuff like that. And look, you've done work with fractions prior to fifth grade and stuff like that.
Yeah.
So you got the idea there. Okay, but now I want to show one more division question before we move on to the next piece of business and stuff like that, because what you'll ultimately see when you get a little bit deeper into things, that sometimes it's not going to just strictly be the number that you're the dividend is not going to strictly be the one that has the decimal. It might, but in some cases it won't. But where you've got to make a different fuss is when the divisor has a decimal on it.
So like
wait, okay. Well, wait. Let me come up with one that is calculable here.
But.
Okay, we're gonna have some fun here then. All right.
Oh
we'll
no!
See. Well,
what have I done?
Well, I wanted to know if okay, here, wait. Let me come up with one I know. What are you doing?
I want to all be the same color.
Picky. Anyway. Oh good. Oh good Lord.
I don't know why.
So that's the deal there. All right. So here's the issue here. Because the thing is, when you divide, you always want to make sure that you're dividing by a whole. You're going to have to basically eliminate it. You're going to turn it into a whole number.
Oh, so you turn it into like 25, and then you like multiply.
Okay, well,
like this.
Wait, okay, no. Okay, hold it. Time. But here's the thing: you can't just erase the decimal and just do the division willy-nilly. You can't do that. The problem is you have to recognize that in erasing the decimal, you've essentially taken the decimal point and you have moved it over to the right because you had one decimal place there to begin with. So here's the thing. Since you eliminated one decimal place, that means this number is going to also have to move its decimal one to the right to balance out, because you have to keep both. You have to retain the general value of both numbers. So the decimal point moves there now as a result, and because of this, now you have to fill a space here. To fill that space, you're going to gain a 0. So this now is the division that you're doing: 52,500 divided by 25. Now again, bear in mind when you do this division, okay. This number, after you move places over, it might not have a decimal anymore. It might be a whole number, or depending on if this had more decimal places than this did, it may still be a decimal in and of itself. Doesn't matter. The point is now you pick up the process from there and conduct your divisions as you were before. And it ends, okay, right? And 0 for that. So 2,100 is what we end up with. Yes, if you get to a 0 and you've got zeros left before everything's said and done, 2 divisions of decimals, that's what you're going to see, and that's how you'll handle that. Okay, so we were able to get something like that to work. And okay, yeah, no, I didn't say that. I told you got to get some self-control exhibited and stuff like that. So that. I'm just sending a message to them right now, just reminding them that we are active here on the live stream here. We still got plenty of time here, so anybody that wants to
so like 25 minutes left.
At least. Again, I'll go as long as people
Imagine we end up doing this for like 2 hours.
I hope we can one day.
And like we just lose.
So we got that. Okay. So I wanted to just get that in place or whatever. So anywho, so that's the story there.
So wait.
I want to go into another type of voting right now. This type of voting is a little bit different, okay, from from the election type of voting and stuff like that. So we're getting out of that. This type of voting now is not really. Okay, there is a question of power involved in this type of.
Mr. Smiley will return.
Anyway, all right. So let me explain the point here of what's happening on this. Okay, this whatever name it is that you have for it and stuff like that. Well, no, not really a primary thing.
No,
That's not like let's suppose like okay here real quick. Let's look this up for example. Let's take like the fourth. I have no idea. Okay. All right, here, electoral college map. I'm gonna look this up here. Now I'm just gonna focus just for this example. I'm gonna focus on just like the immediate states like around this area and this region and stuff like that. Okay, so let's just suppose for example. So I'm taking like I'm taking the tri-state area, and since Pennsylvania is still near and dear to these four states. Okay, let's say that okay. Let's say that New York has 29 electoral.
Are we actually going by votes?
Yes, they have 20 electoral votes. We're third in the immediate area. We've got 14, and then Connecticut. Let's say that these four states. Let's say that they were to create some type of like. Let's say that they were forming some type of like
Alliance.
Alliance or group. Let's say they wanted to form in and of their own body. Now the thing is that as each decisions are made, some the whole group. Some states might say yes, some states might say no. Okay, so that's the nature there. Now now the question is, let's say that when a state says yes, okay, let's suppose that when a state says yes, their electoral votes count toward the votes that are needed to make this decision. Okay, you know what I'm saying? So like let's suppose that on a particular thing, let's say that New York and New Jersey say yes to whatever is being proposed.
New Jersey and Connecticut.
Okay, all right. So if New Jersey and Connecticut say yes to a particular motion and stuff like that, okay, how then? Because New Jersey's got 14, Connecticut's got 7. Okay, so that means there's 21 points. So that means there's 21 point circumstance. Would this whatever bill or law they want to propose, would this law pass? Key is this. All right. The idea of what? Okay, can we? Okay, all right. Enough of the drawing. Enough of the drawing.
Like this?
Yes.
Whatever that thing is.
Yes and no. Okay. But why it's called weighted is because each of the people involved. New York's decision. Wait. Stop drawing for a second.
No, so
New York's decision.
They contribute, like.
Yeah, I mean, now understand. And there could be some. I mean, they don't all have to have different weights. There could be some weighted voting systems where some people's decision. But here's the point. Okay, follow me on this. The focus here is that in order for a decision to pass, there has to be a certain number of points obtained within all the votes in order. That's what's referred to as a quota.
It's a quota.
All right. Again, like I just said, that's
so it's like
you're gonna see is that a quota. There's going to be a certain range of numbers that a quota can possibly need. Okay. At the very least, more than half, more than 50% of all the. Okay, so there's 70 total points on the table here. Now, if we for 50% is
30.
Okay, so the thing. Okay, so that means you've got to be at least more than half. So what that means is the smallest possible number that could be put here
is 35 equals half, so it has to be
So in this case, Q can be anything in this case from 36.
Oh, no.
Stop worrying about fractions.
Something like that?
Don't get too heavily involved in that. You're worried about the whole number itself. Okay, beyond the half, you don't need inclusive. All right, so that's what you want to see. So what? But now the focus that I really want to look at here is, okay, let's suppose that we know to pass. Let's say that the quota had to be at least 50. So here's what I want to know. I want to know what combinations of these four people. But listen by the numbers. Don't worry about who's who. Just worry about the numbers themselves. Okay. So you
then he had
that's exactly 50. Okay.
Dang.
All right. So what's another combination?
Okay. That?
Let's see if that would work. Let's see. 14 and 7 would give you 21. 21 plus 20 would only that would only give you 41. So that's no good. Okay, stop. So 41, so 49 plus the 7, that would give you 56. So that's more than enough. Okay. So you got that combination. Okay. And you tried the combination that did not have the 29, so that didn't work. And now technically there's one more combination that would give you a total of 50. What's the one remaining combination? If what happens? I need it over here. No, because there's a light shining over here. I want to make sure the word that I write is thing. All of these are example, what are called winning coalitions. A coalition meaning any group of people that bands together and says yes to a particular decision. Okay, but like I said, in a business structure, that's what they're called. They're called coalition.
The grand group.
Like I said, where everyone says yes. Okay. Yeah. Where everyone says yes, where it's a unanimous decision. That's what we try to look at there. Okay. So the whole idea is this structure, like everybody brings an individual weight to the table, and based on who says yes and who says no, that determines the decision. Now, what you'll ultimately find, and I'm not going to go that deep into it right now, but one of the things that you'll see is that when you've come up with like all your winning combinations, what you find is that you can see that certain people's decisions carry more instance. You could see in these four combinations, the New York's vote was necessary in all four of these winning coalitions. So
that means it's like
their vote carried 4 units of power, whereas, for instance, everyone else's based on this, and depending on the nature of how big the quota is and what everybody's of power. So you might even have some circumstances where certain people that have more weight to their vote, they might have much more of the power. They might even sometimes have all of the power. That's what's called being a dictator. And you may have some people whose votes, regardless of whether they say yes or no, carry no power in the decision at all, because it's a little discreet for you and for you folks out there, so you have an idea of how it is that all works, and stuff like that. This guy has
most of the power. This guy.
A lot of drawings into her work to further the concepts or whatever. Okay, no, all right, but not that. But her name is the person I'm talking about. Her name she goes on YouTube by the name of Vihart, Vihart, and several years ago she did and I think occasionally she still puts up some videos and stuff like that, where like said she has her notebook work for the math that she does. She has it on fast forward while she does the narration, and while she does the voiceover and stuff like that. So no, I totally get it. I understand it, however. But if there's any one video I definitely recommend in terms of Vihart's work and stuff like that, folks, is that yeah, I mean, I've seen several of her pieces, but if there's one I absolutely recommend, and any of you that are understand, the concept that, but the premise of how she explains how to get to logarithms. Matter of fact, the video is called "How I Feel About Logarithms." But I recommend that anybody on any level of math, not just algebra 2, but any level underneath, also to it that this pattern, or as she refers to it, and I've told my high school students this concept a lot, but the whole idea is being able to do a multiplication repeatedly and stuff like that. The whole idea of what Weihart explained. So it's 22 times another 22 times another 22 times another 22 times another 22. You're repeatedly multiplying with the same number over and as a whole and stuff like that. But the whole idea is the calculations that you get after each multiplication, those numbers have a, so that's the way you want to look at that. So that's the nature of that business or whatever. Okay.
Goodbye, my friends.
yes, we do have to say goodbye to them. And for lack of anything else at the moment, for what we got here, we again, K through 12 math concepts that we could get within this, with all the distance learning that everybody is doing here over these next 2 weeks or however long we got to do this. Please, by all means, keep on joining us here every day, 2 p.m. Eastern Daylight Time. And again, please throw a like up on the video. Please subscribe to the channel, hit that bell notification if it lets you to stop a couple, and ultimately very soon down the road we will be able to post brand new videos with them. I will do some level, help us out here, keep us company, and like I said, let's continue to do what we've got to do. All right, get him to keep cool, as it were. All right.
He was in the last live stream. He was throwing Wilma.
They saw
Wilma the platypus.
Now you're hitting the screen.
Oh no! And it hit, and Wilma hit me, and it was like, didn't actually go like this.
Yeah. Yeah. Join us again. Tell your friends, and we will catch up with you guys very, very soon. Yes, hit that bell notification to stay informed of what we're doing next. All right. So I will see you guys tomorrow. Take care. Yeah, this is me, Brian Sapinski. This is Brianna, and so long, guys.
Bye, friends. Bye. Bye.
Ba-dum-bum-bum.